Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on October 10th, 2025, about 3 days ago. The big move in this paper is a unified method that optimizes text and non-text prompts together, delivering better accuracy than text-only methods and cutting the evaluation budget by 42%, reaching uniform strategy performance with only 30% of the budget. The paper is titled Multimodal Prompt Optimization: Why Not Leverage Multiple Modalities for MLLMs? And as we'll see later, the implications for prompt design are quite significant. In short, this paper introduces the Multimodal Prompt Optimizer, combining alignment-preserving updates with a Bayesian selection strategy across images, videos, and molecules. Also, the authors shared the official MPO code on GitHub. You'll find a Python implementation with SRC modules, a MLLM server script, and runnable entry points via main.py and main.sh. It includes requirements, clear setup steps, configurable model and task options, logging, and guidance to add new tasks by extending base task. Alright. Figure 1 contrasts two strategies and highlights why prompts should include non-text signals. The left panel contrasts text-only optimization that stays in a unimodal space, which limits what the model can infer from a long description. The right panel illustrates multimodal optimization that pairs updated text with optimized images, so the model receives concise visual cues that disambiguate categories. The message is simple. Richer prompts mean better guidance for multimodal large language models. Well, Figure 2 shows how the optimizer works end-to-end. Panel A sketches the alignment-preserving exploration, where a single textual feedback stream refines the text prompt and conditions a generator to create or edit the image or other modality via generation, edit, or mix operators. Panel B details the Bayesian upper confidence bound selection, which means using a probability model to prefer candidates that look promising while still exploring. The warm start uses the parent prompt's performance to initialize the prior, so the search finds strong children faster. Okay, Table 1 makes the headline clear. The multimodal optimizer wins broadly across images, videos, and molecules. The average score reaches 65, which beats the strongest text-only optimizer that sits at 59. The biggest margins appear on Plant Village and VANE Bench, showing that optimized visuals and text together lift both classification and question answering. These gains matter because they come from the same evaluation budget, so the method delivers better quality without extra trials. So while Table 1 showed broad accuracy gains, Figure 5 shows why the selection strategy matters for budget. Figure 5 shows that the prior inherited Bayesian upper confidence bound reaches the uniform strategy using about 30% of the budget. It also matches or exceeds standard upper confidence bound and the without prior variant with roughly half the evaluations. Bayesian upper confidence bound balances exploration and exploitation with a probability model, and prior inheritance warms each child with its parent's performance, so promising prompts get tested sooner. Wrapping up, two takeaways stand out. Joint optimization of text and non-text prompts consistently beats text-only tuning, and the prior inherited Bayesian upper confidence bound cuts trials sharply while keeping accuracy high. The implication is clear. Prompt design becomes a multimodal engineering task, enabling cheaper, stronger deployments across images, videos, and molecules. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.